Hello. So in this video, we're going to do module 54 about the production function. So there's just one check your understanding, and it has three parts for this one. So part A gives you this kind of scenario where it has Bernie's ice making company and it produces ice cubes using a 10-ton machine and electricity along with water, which we'll ignore for as an input. The quantity of output measured in pounds of ice is given in the table, and you can see it's kind of a little bit on the next page. What's the fixed input? What's the variable? So the fixed input is the 10-ton machine, right? That's the fixed because it's fixed in terms of kind of its ability to you can't get another one, at least in the short run, right? You kind of just have this thing and it can make 10 tons, I guess. I don't really know what the tons there refers to, but the variable input would be electricity because if you run the machine more, you can use more electricity. In addition, the water is also variable, but it does tell us to ignore that. So for part B, it says construct a table showing marginal product of the variable input. Does it show diminishing returns? So we'll kind of do part B over here. And so we'd say quantity of electricity, right, which is the input. And so we have 0, 1, 2, 3, 4. And then quantity of output, which is the ice. And so we just have inputs and outputs. That's really all the production function is. And it's saying we want the marginal product of the variable input. So in other words, what's the change in the amount of output for every time we have one more input? So we are given that it goes 0, 1,000, 1,800, 2,400. And actually, you don't need to rewrite these for yourself. What you just need is actually this column, the input column, and then the marginal product column, which would be 1,000, 800, 600, and 400. And we can observe that it's decreasing, right? It's diminishing. It's still positive, but it's 1,800, 600, 400. So yes, it does. We just write yes. Okay, now part C says, suppose a 50% increase in the size of the fixed input increases output by 100% for any amount of the variable inputs. What's the fixed input now? Construct a table showing the output and marginal product in this case. And so it's now a 15-ton machine, right? So that's now the fixed input. And it gives us that that the output goes up by 100% regardless of for each of the variable inputs. So you would still have like quantity of electricity 0, 1, 2, 3, 4, but the quantity of ice will be doubled from where it was, and it still wants the marginal product. So we'll do quantity of input and quantity of output and marginal product. And so 0, 1, 2, 3, 4. And quantity of output, now these numbers are going to be doubled because it's 100% increase. Double of nothing's nothing. 2,000, 3,600, 4,800. Again, I'm just doubling these numbers, and 5,600. And now the marginal products, these are just going to be doubled as well. So it's 2,000, 1,600, 1,200, and 800. 800. Squiggly 100. And so, yes, it still shows diminishing marginal returns, right? Every time you add a unit of input, if you have fixed inputs, every time you add a unit of a variable input, you're still going to have diminishing marginal returns to that variable input. So now let's take a look at the multiple choice questions. Multiple choice number 1 says production function shows the relationship between inputs and outputs. So that's D. It's just what production function is. Number 2, which of the following defines the short run? So that's any time period where one of the variables is fixed, right? Remember that part. And so less than a year, no. All inputs are fixed, no. No inputs are variable. No, that doesn't make any sense. That's the same as B. D, when only one input is variable, not necessarily when at least one input is fixed, that is correct. E. Like a brain fart on number B and C. Number 3, the slope of the total product curve is known as marginal product. So it's just the derivative function of it. So where is that? That's A. Okay. By the way, the slopes of all of the total functions that we look at are always going to be the marginal function. So if you have total cost, the slope is the marginal cost curve, and so forth. Number 4, diminishing returns to an input ensures that as a firm continues to produce, total product curve will have what kind of slope? So the total product curve kind of just for reference kind of does one of these, and it just kind of starts to flatten out. So it's a positive, right? The slope of this line is positive, and I should just write like, we would say like output, just so you know this is output over inputs. And so like as you get more inputs, the amount of output that you get out of each input rises, but at a decreasing rate. And so we would say it's positive, but it's decreasing. So B. And number 5 is historically the limits imposed by diminishing returns have been alleviated by, and so this is something from the reading, but it's the idea that you need more fixed inputs, right? So you have this limit up here, of marginal product 1,800, 600, 400. The way you alleviate that is by buying a bigger machine, right? Getting a better machine. And so out of these, investment in capital would be buying a bigger machine. So correct answer is A. Although I do like Thomas Malthus is just kind of thrown in there as like, hey, he's the one who's doing it. Number 2, use the data in the table below to graph the production function and the marginal product of labor. Do the data show diminishing returns to labor? Explain. Okay, so free response number 2. And so for this one, it wants us to graph a production function, which is output over input, right? Quantity of input, quantity of output. And so we know it's probably going to look something like what I just drew there, but and actually there's a picture of it right there too. But let's go ahead and see. So we've got 8 units of labor. 1, 2, 3, 4, 5, 6, 7, 8. And the maximum amount of output looks like it's going to be 96. So let's just say 100, just to keep it nice round numbers. And we'll say 50 and 25 and 75, right? I'm just trying to give us some ranges here. We know that there's 0 and 0, so we'll plot that point. And these are just going to be kind of rough, right? So let's see here. 1 is at 19, so that's like right there. 2 is at 36, so maybe here. 3 is at 51. 4 is at 64. Starting to flatten out. 75 and 84, 91 and 96. And lo and behold, it kind of does start to just flatten out like that. So we would say yes, it does show diminishing returns because, right, the line flattens, right, the slope, we could actually be really specific here, slope flattens out. You could also say the marginal product, and it wants us to graph the marginal product of labor. So in just a second, you could graph that as well below. So we'll kind of do one of these. So quantity of input, and this one's going to be marginal product. So 2, 3, 4, 5, 6, 7, 8. That's going to look terrible. And so let's just kind of do the marginal product over here. So it's going to be the change of like 0 to 19. So quantity of input 1, 2, 3, 4, 5, 6, 7, 8. And so it'll be 19. And then 36 minus 19 is 17. And 15. And then 64 minus 51 is 13. And 11. And 84 minus 75 is 9. 91 minus 84 is 7. And 96 to 90, there's 5. So the most here is going to be 20, 10, 5, 15. And so we're gonna actually see the marginal product curve as we build this, and you'll be able to see the diminishing returns. So 1 and 19, 2 and 17, 3 and 15, So whenever the slope doesn't look quite right, just make your dots bigger. 4 and 13, 5 and 11, 6 and 9, 7 and 5. So it's doing one of those, right? And so that is the derivative of this function as well. So that's another piece. So the line of this, right? The TP, the total product line, flattens out, and the marginal product line is downward sloping. So that's what this one is, right? That's the marginal product function. That's the total product function. All right, hopefully this helps you with production function. We'll see you next time.